In our next question, we need to decide if this object is going to float or is it going to sink. So we know that the mass is 1,500 grams. So I'm going to draw it underwater, and I'm also going to convert. We know to convert this, it becomes 1.5 kilograms. And I'm going to gently scratch that out so I don't try to use 1,500. 1.5 kilograms. Now it's underwater. We need to decide what forces are acting on this object. Well, we know that there's a force pulling down due to gravity, Fg. And remember, that is your mass, 1.5, times gravity. Normally it's 9.8. But to keep things simple, let's use 10. So, the downward force, or gravitational force, is 15 newtons. So, would it be acceptable to just say F ma? Of course not, because we haven't considered all forces. What force is pushing up on an object underwater? If you said the buoyant force, you would be correct. So how do we calculate buoyant force? I'm going to draw in that arrow up, buoyant force. We learned that the buoyant force is equal to the water that you move out of the way or displace. So 2.5 liters of water. I need to calculate the buoyant force. So it's going to be equal to the mass of the water times G. G in this problem is 10. We're going to keep it simple. How much water is 2.5 liters? What is the mass equivalent? Well, you know in chemistry, 1 liter of water is equal to 1 kilogram. That's nice and simple. I can do that without a calculator. So 2.5 liters of water is equal to 2.5 kilograms of water. So to calculate the buoyant force, all I'm going to do is say we have exactly 2.5 kilograms of water, multiply that by 10 to get 25 newtons. So when I take this rock or object and I push it underwater, I'm going to move 2.5 liters of water out of the way, which is 25 newtons. So the first question in our problem, will it sink or float? Because the weight of the water is larger than the weight of the object, this object has a buoyant force of 25 newtons and a downward force or weight of 15 newtons. Because the upward force is larger, 25 is larger than 15, my object will float. So the first answer, my object does float. The second question is when you hold it underwater and you release it, what will be the initial acceleration? In order to calculate that, we need a formula that has net force and acceleration in it. Well, that's a simple Newton's second law, F ma. So in my diagram, we have a downward force of 15, an upward force of 25. I will subtract these two forces since they are in opposite directions, and the net force is 25 minus 15. The mass of the rock was given 1.5 kilograms. And now all I have to do is solve this simple equation. 10 equals 1.5 times A. So my acceleration is going to be 10 divided by 1.5, which is 6.67 meters per second squared.